Hey everybody, it's Jason from Code Monkeys and welcome to another Code Monkeys tutorial. In today's video, we're going to be looking at the basic components, terminology, and concepts of lithium polymer batteries, aka LiPo batteries. And these batteries are used for powering your RC drones because they are generally lightweight and are able to sufficiently store energy. So here we have two distinct LiPo batteries, and the first thing you may notice is the size discrepancy between the two. So the larger LiPo battery sold by Z-Power has a capacity of 6,000 milliamp hours with a C rating or discharge rate of 60, and the smaller LiPo battery sold by Venom has a capacity of 430 milliamp hours with a C rating or discharge rate of 30. And you may see other values for the capacity of these batteries. For example, you may see a 2000 milliamp hour battery, a 2200 milliamp hour battery, or a 4000 milliamp hour battery, and a bunch of other values. And another important thing to notice is that as the size of these batteries increase, the capacity of the batteries will also increase. And generally, the larger the capacity of your battery, the longer your flight time will be. But there may be cases where the increased weight of the battery will adversely affect the performance of your drone. So in a future video, we will discuss how to properly choose the capacity of your battery and the weight of your battery based off of the other components in your model. So now let's get back to the idea of milliamp hours. So this means that, for example, the 6,000 milliamp hour battery will provide a 6,000 milliamp or 6 amp current for 1 hour. And the 430 milliamp hour battery will provide a 430 milliamp or 0.43 amp current for 1 hour. And to determine the amount of current that you can safely draw from your battery without damaging it, you simply take the C rating of your battery and multiply it by the capacity of your battery. So for example, for the 6,000 milliamp hour LiPo, the current that can be safely drawn from it is determined by first dividing 6,000 milliamps by 1,000 to get 6 amps, which is then multiplied by the C rating of the battery, which is 60. So the current that can be safely drawn is 60 times 6, which is 360 amps. And for the 430 milliamp hour LiPo, the current that can be safely drawn is once again found by taking the 430 milliamps, dividing it by 1000, which is 0.43 amps, and then multiplying it by its C rating, which is 30. So the current that can be safely drawn is 0.43 times 30, which is 12.9 amps. And notice that the higher the C rating or discharge rate of the battery, the higher the current your battery can discharge, which means a higher current can be used to power the motors and any other components that may need it. And the current that can be safely drawn by your battery is also called the continuous current. Also, on some batteries you may see the C rating written as 25-45C, for example. And here the first number, 25, is the continuous C rating, and the 45 is the burst rating. And the burst rating means for a short period of time, approximately 10 to 30 seconds, you can draw an even higher current without damaging the battery. So if you had, for example, a battery with a 2,200 milliamp hour capacity, the continuous current that can be drawn is found by taking the 2,200 milliamps, dividing it by 1,000, which is equal to 2.2 amps, and then multiplying that by 25, which gives us a continuous current of 55 amps. And the burst current is found by taking that 2.2 amps, multiplying it by 45, and that will give us a burst current of 99 amps. So for approximately 10 to 30 seconds, we can draw 99 amps from that battery without damaging it. And for these two batteries, the C rating that is given is the continuous C rating. And another important factor to look at is the voltage of the batteries, because the voltage of the batteries will tell you how much power the batteries will supply. So the voltage of the battery is determined by the number of cells of the batteries. And for example, the 6,000 milliamp hour battery has 3 cells. We have 1 cell, 2 cell, 3 cells, and these cells are connected in series. And here the overall voltage is determined by multiplying 3, which is the number of cells, by 3.7 volts, which is 11.1 volts. And each cell has a voltage of 3.7 volts per cell, because this is how companies and manufacturers label their batteries when selling them, because the nominal or storage value of each cell is 3.7 volts. And we will discuss the nominal or storage value of your battery in a later video when we discuss how to charge your battery. So for the 430 milliamp hour battery, it has a voltage rating of 7.4 volts, which means it is a 2-cell battery where each cell has a voltage rating of 3.7 volts. And most batteries will have the number of cells and the type of connection of those cells written on it. Neither of these batteries have that, but you can determine the number of cells by looking at the overall voltage. And the 2-cell battery, for example, would have a 2S written on it, and a 3-cell battery would have a 3S written on it, and the S tells you that you would have all of your cells connected in series. And you may also see, for example, 3S1P, where P means a parallel connection. So this would mean that you would have 3 cells connected in series with 1 parallel connection, which is actually the same thing as just writing 3S. And if you had, for example, a battery with 3S2P written on it, this would mean that you have 3 cells connected in series and then another 3 cells connected in series, and then those cells are then connected in parallel. But for the majority of these LiPo batteries, the cells will just be connected in series. And the last thing we are going to look at is the connectors of these batteries. So the black and red wires are the negative and positive battery leads. And they're what gets connected to your electronic speed controllers, ESCs, which we discussed in a previous video, and to your charger. So here you'll see the positive battery lead, which is this red wire, and the negative battery lead, which is this black wire for the 6000 milliamp hour battery. And for the 430 milliamp hour battery, you will see the black wire, which is once again the negative battery lead, and the positive battery lead, which is the red wire. And here you'll notice that the 430 milliamp hour battery has a JST connector already soldered onto it, whereas the 600 milliamp hour battery came with an XT60 connector and a Dean's connector. However, you would have to manually solder these connectors onto your battery. So when purchasing your battery, make sure that the connectors of your battery match the connectors of your ESCs and of your charger. Otherwise, you're going to have to buy new connectors or an adapter, or make an adapter yourself. And in a future video, we will demonstrate how to properly solder connectors onto your battery and how to make an adapter. And that's it for this video. I hope you found it helpful, and if you did, be sure to comment, like, and subscribe. And in the next video, we will be discussing how to properly charge your LiPo batteries, the different types of charging, for example, normal charge, balance charge, fast charge, and storage charge, as well as some other tools that are useful when handling batteries, such as battery meters and low voltage alarms. And then we will show you how to charge your LiPo battery using a 4-button charger. Alright, thanks a lot for watching the video, and we'll see you in the next video.